In this video, we'll discuss about regulation of acid-base balance. So first we want to know what is acid, what is base, what is buffer solution, what is pH, regulation of acid-base balance. So first we going to see what is acid. Any chemical substance which have capacity to can liberate or release hydrogen ion in solution is termed as acid. Any chemical substances which have capacity to liberate or release hydrogen ion in a solution. It can be either strong or weak acid. It depends upon how much hydrogen ion delivered, and liberate more hydrogen ion means strong acid, and released less amount of hydrogen ion means weak acid. So strong acid example HCl, sulfuric acid, phosphoric acid, nitric acid. Weak acid example acetic acid, carbonic acid, hydroxy, carboxylic acid. So strong acid HCl, sulfuric acid, phosphoric acid, nitric acid. Weak acid example acetic acid, carbonic acid and carboxylic acid. These are the examples. What are the sources of acid? Metabolic sources of acid. Two types. First one is volatile acid. Second one is fixed acid. Volatile acid easily evaporated at a normal room temperature. This acid produced by oxidative metabolism of aldehyde, fat, protein. Name itself indicate volatile. So it is excreted via lungs as carbon dioxide gas. Example carbonic acid. So first type is volatile acid. This acid produced by oxidative metabolism of aldehyde, fat and proteins. It is excreted via lungs as carbon dioxide gas. Example carbonic acid. Second one is fixed acids. These are the acids once produced by our body. Acids once produced, they remain in body fluids until eliminated by kidneys. These are produced during catabolism of amino acid, phospholipid, nucleic acid. Example sulfuric acid, organic acid, phosphoric acid. So second type of acid, fixed acid. This one produced by they remain in body fluid until eliminated by kidney. They produced during catabolism of amino acid, phospholipid and nucleic acid. Example sulfuric acid, organic acid and phosphoric acid. So these are the two important sources, volatile acid and fixed acid. Now we are going to see about bases. Bases are nothing but they chemical act as proton molecules is called bases. So bases nothing but chemicals act as proton acceptor. This molecule name is called as base. Substances which act as proton acceptor so may be strong or weak bases. Strong accept more number of proton is strong. So example sodium hydroxide, potassium hydroxide. Weak acids example bicarbonate and ammonia. Bicarbonate and ammonia. Strong base example sodium hydroxide, potassium hydroxide. Weak alkali example bicarbonate and ammonia. Physiologically important bases bicarbonate, biphosphates. So physiologically important bases bicarbonate and biphosphate. Next, Henderson-Hasselbalch equation. Henderson-Hasselbalch equation. This equation was framed by two scientists. So that's why it have that name, Henderson-Hasselbalch equation. pH is equal to pKa plus log concentration base divided by concentration acid. This one provided the relationship of pH, pKa, concentration of base and acid. It is expressed to read when the concentration of base and acid are same, when pH is equal to pKa. pKa is equal to pH at which acid is half ionized. pKa, it is a pH in which any acid that is half ionized. It is used to drive the pH. The pKa value is used to drive the pH value. Then buffers. What are buffers? These are the solution which resist the change in the pH when acid or alkali is added. So how we will define solution which resist the changes in pH when acid or alkali is added. Then composition, mixture of weak acid plus salt plus strong base, or it can be mixture of weak base, salt and strong acid. Example, bicarbonate buffer system or phosphate buffer system. Next, pH. What is pH? It is negative log of hydrogen ion concentration in the plasma. Negative log of hydrogen ion concentration. pH is equal to minus log of hydrogen ion. Normal pH of that plasma is 7.35 to 7.45. If the pH is below 7.35, the plasma is called as acidemia. That means this condition name is called as acidosis. The pH concentration is increases. Hydrogen ion increases means acidosis. The pH more than 7.45 name is called as alkalosis. Here hydrogen concentration decreases. So normal pH range 7.35 to 7.45. Below 3.5 means acidosis, more than 7.45 means alkalosis. So neutral 7, 5 to 6 slightly acidic, 8 to 9 slightly alkaline, then 10 to 11 moderate alkaline pH. Here highly alkaline. This one is moderate acidic pH, 1 to 2 highly acidic pH. This one is the pH scale. Next, why the pH regulation is needed? Because small changes in pH causes major disturbance in our body. Most enzyme function only in the narrow pH. It also affects body electrolytes level. It affects biological cell membrane function and altered protein function. Then through this problem can leads to death if there is severe changes. So why this one is needed? Small changes also causes major disturbance in our body. Most of the enzyme function in narrow pH only. It affected body electrolytes level. It affected membrane functions and protein functions. Then it can leads to death in severe changes. That's why pH regulation is needed. Regulation of blood pH. To maintain blood pH at a normal level, there are three primary systems that regulate the concentration of hydrogen ion in body fluids. There are chemical buffer or blood buffer. It have immediate action. Second one is respiratory system. It have acute action. Third one is renal system. It have slow action. So three primary system: chemical or blood buffer system, respiratory system, and renal system. Now we will discuss one by one. First one is chemical buffer. These are the first line defense against the pH change. This one is the first line defense against the pH change. Whenever there is pH change, there are first one to come pH change. They react immediately. This one activate within a minute. Then here they does not eliminate hydrogen ion, rather than try to neutralize it. So this one is the first line defense against the pH changes. They react immediately. Here they does not eliminate any hydrogen ion, rather than try to neutralize it. They have four different type of chemical buffer. One is bicarbonate buffer, second one is phosphate, third one is protein buffer, fourth one is hemoglobin buffer. So the four different type. First one is bicarbonate. First one is bicarbonate buffer. It is most important extracellular fluid buffer, but it can also be a intracellular fluid buffer. It roughly account for 65% of plasma buffering capacity and 40% of whole body buffering capacity. It have two constituent: base bicarbonate, which regulated by kidney; acid carbonic acid, which was regulated by our lungs. So first one is bicarbonate buffer, most important extracellular fluid and intracellular fluid buffer also. Roughly 65% presented in plasma buffering capacity and 40% presented whole body. Then it have two important constituent, base and acid. Base bicarbonate regulated by kidney, acid carbonic acid regulated by lungs. pKa value essential for buffering. Bicarbonate pKa value 6.1. Then alkali reservoir. What is alkali reservoir? It is represented by amount of bicarbonate in plasma which is freely available. So it is represented by amount of bicarbonate in plasma which is freely available, not used for neutralizing action. This one not used for neutralizing action. Simple word, these are the amount of bicarbonate which are kept for the neutralizing action. Okay, these are amount of bicarbonate which are kept for neutralizing action. It is need whenever there is acid load. This one very essential, because whenever acid load increase, bicarbonate to neutralized. Second one is phosphate buffer. It is an intracellular and renal tubular fluid buffer. Its concentration in plasma is low. Its pKa value is 6.8. Any substance or chemical which have pKa value near to the normal pH, they have maximum buffering capacity. It is effective in wide range of pH as it has more than one ionizable group. Next one, protein buffer in blood among in blood we have plasma protein. Among plasma protein, mainly albumin can act as buffer because the albumin have many dissociable acidic and basic group. For example, there is acidosis. This albumin disassociated with the basic group and goes under neutralization. Amino acid can also act as protein buffer, but not all amino acid. Here amino acid having histidine imidazole group can act as effective buffer as pKa of histidine is 6.1. Next, hemoglobin buffer. This one is our tissue containing carbon dioxide. This carbon dioxide now it will enter to RBC. Now this carbon dioxide will bind with water molecules to form carbonic acid. In this carbonic acid acted upon enzyme carbonic dehydrogenase enzyme, it will it will form hydrogen plus HCO3. Now this H will bind with the hemoglobin. Normally RBC the HB bind with oxygen. When this hydrogen ion concentration is increased, this hydrogen ion go and bind with HB. So it form HHB. Now this HHB enter to the lungs. Now it will enter to lungs. This RBC have H2CO3 and HHB. Now it have H2CO3 and HHB. Now this HHB enter to lungs. Now lungs rich in oxygen. Here rich amount of oxygen is presented. So HHB plus O2 to form HbO2 plus hydrogen. Now this hydrogen is available. This hydrogen ion is available. This hydrogen ion bind with bicarbonate HCO3 to form carbonic acid. Now this carbonic acid released water and carbon dioxide get evaporated to the other respiration. So by this manner Hb acts as a buffering molecules. Tissue containing carbon dioxide, it will enter to RBC, it will form HHB. This HHB enter to lungs, then it will form H2O and CO2. So that water and CO2 get evaporated to other respiration. By this manner Hb act as a buffering molecules. Now we are going to see respiratory regulations. These are the second line defense. It takes within our rate of respiration is under the control of chemoreceptor. It is presented in our brain system. This chemoreceptor it highly sensitive to change pH of blood. When fall in pH acidosis, it stimulate the stimulation of respiratory center. The stimulation of respiratory center is called hyperventilation. As a result, hyperventilation decreases in partial pressure of carbon dioxide. As a result, decreases of partial pressure of carbon dioxide. This one is the temporary mechanism. So decrease acidity. Then what happen in blood pH high? Blood pH alkaline in nature and it in turn inhabit that respiratory center causing hypoventilation during frequency of respiration and it causes carbon dioxide retention. As a result, partial pressure of carbon dioxide increases. Carbon dioxide acidic in nature, so alkalinity decreases. So when what happened here, pH high means here in turn inhabit that respiration center causing hypoventilation. Then it causes carbon dioxide retention. As a result, that partial pressure of carbon dioxide increases, so alkalinity will decreases. Then next one is renal regulation. Renal have important function to regulate pH in extracellular fluid. It provided permanent solution of acid-base disorders. This one is slow but best regulator. It take more than 48 hours to activate function on it. So it provided permanent solution of acid-base disorder. It have four mechanism: excretion of hydrogen ion, then reabsorption of bicarbonate, then excretion of hydrogen ion, then excretion of ammonium ion. We have lumen, proximal tubules and distal tubules. This one is blood. Lumen means urine trained here. Urine trained here. This is proximal tubules. This one is the distal tubules. In proximal tubules, the bicarbonate being reabsorbed from the urine. So lumen to proximal tubule, then into the blood. Then NH3 ion sent or excreted out of lumen, whereas that proton hydrogen ion are being taken from blood. They excreted into lumen to that urine out of the body. This hydrogen ion combined with this NH3, then it form ammonia. Then it form ammonium ion. This ammonium ion cannot reabsorb. This is what happening in renal system. So this one excreted in the form of urine. As this situation, blood pH is low, small acidic condition, what the body must do? HCO3 has reabsorbed the bicarbonate to increase alkaline nature in the blood, whereas proton hydrogen ion sent out of blood decreases acidity to the blood. This is what is happening in renal system in blood pH. So this HCO3 reabsorbed by proximal tubule, this hydrogen ion excretion, then NH3 and NH4 excreted from proximal tubule. It is excreted in the form of urine. In this video, we'll discuss about four basic type of acid-base imbalance. We have understand acid-base metabolism, pH 7.35 to 7.45, balance between them. If acidity increases means body shows acidosis, whereas in the blood, base increases means body will be showing features of alkalosis. Below 7.35 acidosis, above 7.4 by alkalosis. So two acidic condition is called acidemia. Two basic condition name is called alkalemia. Acidosis may result from inadequate functions of lungs. Acidosis may result from inadequate functions of lungs, which causes arterial carbon dioxide to accumulate. In lungs, carbon dioxide to be accumulated. This is respiratory acidosis. On the other hand, metabolic acidosis may result from excessive production of metabolic acid, decreased ability of kidney to excrete acid, injection of acid, or loss of alkali. Metabolic acidosis is characterized by primarily decreases in plasma bicarbonate. So here four type of imbalance: metabolic acidosis, metabolic alkalosis, respiratory acidosis and respiratory alkalosis. What are the disorders? Metabolic acidosis means pH, carbon dioxide and bicarbonate level. pH, carbon dioxide and bicarbonate level all 3 decreases. Name is called metabolic acidosis. Metabolic alkalosis means pH, carbon dioxide, bicarbonate all 3 level increases. Respiratory acidosis means pH and bicarbonate level decreases, carbon dioxide level increases. Respiratory alkalosis means pH and bicarbonate level increases, carbon dioxide level decreases. So metabolic acidosis all level decreases. Metabolic alkalosis all level increases. Respiratory acidosis pH and bicarbonate level decreases, carbon dioxide level increases. Respiratory alkalosis means pH and bicarbonate level increases, carbon dioxide level decreases. For assessment of acid-base disorder, arterial blood gas analyzer is required. Acid-base disorder by using arterial blood gas analyzers is required. This arterial blood gas analysis having 3 parameter: pH, bicarbonate and partial carbon dioxide. We know normal pH range 7.35 to 7.45. pH level decreases 7.35, name is called acidosis condition. More than 7.45 means alkalosis. Then bicarbonate level less than 22 means metabolic acidosis. More than 26 means metabolic alkalosis. Bicarbonate level decreases less than 35 means respiratory alkalosis. Here more than 45 mercury means this one respiratory acidosis condition. So these are the 4 major primary disorder for acid base imbalance. Now metabolic acidosis, what are the diseases it will causes? Here bicarbonate level decreases, pH level less than 7.35. So it causes diabetic ketoacidosis, lactic acidosis, renal failure, organic acid urea, amino acid urea. Metabolic alkalosis, here pH increases due to increasing amount of bicarbonate or decreasing acid level. It causes vomiting, gastric aspiration, decreasing cerebral blood flow, then hypercalcemia condition and confusion. Next one is respiratory acidosis. Here pH decreasing, bicarbonate level, partial carbon dioxide level increasing. It causes pneumonia, asthma, stroke, then confusion and dyspnea. Then respiratory acidosis, here partial carbon dioxide level decreasing, pH level increasing. It causes pain, anxiety, meningitis, encephalitis, tumor, trauma, septicemia, hypotension and severe anemia.